Hello everyone, this is Victoria Denny G from my MEC 140 Lab 4. Here we're dealing with the potentiometer, and we want to see again, is a review of what we've done before, how the potentiometer controls the light and the
analog values we get from the serial monitor right there.
Here. So before we go into that, I just want to show you the parts of the Arduino again. Here we have the potentiometer. One part of it, one leg of it is connected to the 5 volts. The other leg on the other side right here is connected to the ground over here. You see this green to this black wire connected to the ground over here. And we have this blue wire connects to the analog pin of the potentiometer. Over here we have the LED light and the limiting current resistor. The longer leg of the LED light we see is connected to the resistor, and the other side, the resistor's other leg is connected to the pin, while the other side of the LED is connected to the ground as well. Yeah, so now we just want to control the lights with the potentiometer. See, it turns off. And why is that? This is because we use right here in our code, we used the if statement. So if the sensor value is greater than 600, we want the LED pin to be I. You can see right here that the value being printed by the serial monitor is low. That is why the LED is low. If we want it to be I, we increase this. It's high right here. And we check on our serial monitor, it is greater than 600. Because we said right here, if it's greater than 600, we want it to be I. Because it's greater than 600, the LED light is turned on. Once it's lower, you can see right here that is lower than 600. So right here we have the Arduino being connected to the light tracker. We want to use the light tracker to check different colors and to see the reaction on the ID program board. So here we're gonna put this. We're gonna put this on the white object first. As we check the object, please. We can see that, yay. The black object, good. And the red object. So in this case, we have the push buttons being connected to the Arduino, and the push buttons are connected to 3 pull-up resistors, since we have 3 push buttons. And we want to use, since the push button is a digital device, we expect the serial monitor to print out values in 1 and 0. We want to use this to control the LEDs, such that when we push the first push button, we want the first LED to turn on, the second LED. When we push the first 2 ones, we expect the third one, and when we push the last one, we want everything to go off according to the code. We're gonna see right here, this is just the connection. We're gonna see right here as I demonstrate it to you. The first push button is being pushed, the first LED comes on. The second one, the second LED. And when we push both, the third LED comes on. And when I push the third push button, everything goes off. Hello. So in this case, we have the LDR connection to the Arduino. Here we have the light dependent resistor being connected to the pull down resistor connected to the ground, and the LDL connected to the positive side of the breadboard, which is in turn connected to this, to the positive or negative side of the Arduino. In turn, we have all of these LEDs connected to the pins and to the current limiting resistors for each one of them. We just want to see how this LDL works. So right now we're going to see how the LEDs react when the light is turned off.
we have little values, smaller values. When turned on, they go back to the larger value, and this goes back off.